Hello there. Today we're going to be going over a little bit of game building. My hope is to build the Game of Life by Conway, and I'm going to try to do it in C. I'm very new to C. I've never really used it much, so I think I'm going to try to build the Game of Life with the graphics library called SDL2, and we'll see how far I get with that. Probably won't finish it all, but right now I just have like a pretty basic window up and running. If I go over here and open up the application, you can see that I have a little square, so nothing too interesting quite yet. I just got some boilerplate up and running with SDL, but yeah, I'm going to be learning how to use this, and I'm just going to kind of be recording the process for fun. So yeah, I've got NeoVim set up, and I am going to be going through this. So let's open up some documentation to get started. Obviously, I've got ChatGPT up and running, as you do these days, and now I'm going to let's go to, how do I want to do this? Let's just look up the standard documentation. Simple direct media layer. I really love it when certain acronyms are desired, and so words just somehow get combined in strange ways in order to make the acronym. I think it's great. Okay, so let's figure out how to actually do this. Humble bundle, blah 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 blah. I would like maybe the GitHub. How do I learn about this? Simple direct media layer. No. You know what? Let's just ask ChatGPT. How do I use SDL2 in C? By the way, I'm not using C++, just C. So I'm hoping to kind of really get down and dirty with C a little bit. Okay, so I have it all set up. I just need to actually use it. Okay, SDL init video. Okay, so that's kind of what I have right now. I've got if SDL init, which I'm not entirely sure what that does, but we can go check it out. It does initialize the SDL library. SDL init simply forwards to calling SDL init subsystem. Therefore, the two may be used interchangeably, though for readability of your code, SDL init subsystem may be preferred. Okay, interesting. Fair enough. I think I'll stick with the current way of doing things, but okay, the file IO, for example, SDL RW from file. In threading, SDL create thread subsystems are initialized by default. Message boxes, SDL simple message box also attempt to work without initializing the video subsystem in hopes of being useful and showing an error dialog, blah, 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 blah. So this is the init function. There are a bunch of different things we can use on it. And then, okay, so we have flogs. We have flags we can use, not flogs, but yeah, we have flags we can use. So obviously here we have an SDL init video flag, which I'm not entirely sure what that does, but I'm guessing it does something important. Perhaps we can ask ChatGPT about that. Let me get, you know what? Let's go over here. Just copy all of this. You could just do a Y and then uppercase G to copy all of the files when you're at the top, by the way. Okay, what is happening here? The C program you shared is a simple SDL2 application designed to create a window, handle basic user input, in this case closing the window, and render a blue square on a white background. That is very true. Let's break down what is happening in this code. Including necessary headers. The program starts by including the necessary header files for SDL2 functionality, as well as standard IO H for input-output operations. Okay, main function. The main function begins by initializing the SDL2 library for video operations using SDL init. Oh, okay, so it's the flag is the specific type of operation that we're using. Okay, that kind of makes sense. So if I go to SDL init again, maybe I'm on the wrong thing at this point. Let's go. I'm new to this, by the way, so if I'm really slow here, no, I'm definitely not doing this right. GD. Where was I before? I must be doing something wrong here. Okay, whatever. That is the thing that actually initializes video. Then we create a window. So we use SDL create window, and that creates a window called the game of life. We have the window position undefined, and that's because if we go to the documentation here, I wonder if I can go further. Okay, so I guess not. Let's do a couple BDs here because I'm guessing that something got wrong there. Let's see, GD. Okay, whatever. It doesn't have the documentation like it did before. I don't know what I must have done something a little bit wrong. Oh shoot, that is not what I meant to do at all. Pay no attention to me. Okay, so we're creating a window, whatever. I'm guessing this is like the width and this is the height. And what I'm gonna do is I'm actually gonna make this a little bit larger. So let's just make that 1,000. And let's actually do 9 by, let's do a 16 by 9. So we'll do 160, 60, and then we'll make this 900 instead. And so now when we run this, we got to do we got to cd to the build directory. We got to do a make. We haven't changed the make file or the cmake file. So then we can do game of life. Bam! Now it's bigger. That's great. This is perfect. I mean, some could argue that the smaller size was a lot more convenient. A lot less annoying to. Takes up less room. It's a lot easier on the eyes, and some people might say that, but for our purposes specifically, we'll use a bigger version. Okay, if Windows equals null. Okay, so we're creating. By the way, since I'm new to C, I'm going to be trying to kind of figure out what all of these things are doing. For example, here we have the window variable, which is a pointer variable, doing this little asterisk here, which means that this is actually going to be pointing at a memory address, which means if it's used somewhere, for example, create renderer, this thing actually wants an SDL window, and it wants a pointer to that window. So we're going to be giving it a memory address. Now, if this wasn't a pointer variable, for example, if I did a little X here, then, well, first of all, it's not actually correct, but then I would have to come over here and do a little bit of a reference instead, I believe. I could be completely wrong about that, and I'm sure I am, but that's kind of my current understanding of it. We've got pointers and we've got references to those. Yeah, we have pointers, references. They're kind of similar, and they help. They're part of the same sort of structure. Okay, so if renderer, we create a renderer. This renderer, I don't know what all of these flags mean. I'm guessing that this is a flag. Flags used when creating a rendering context. SDL render accelerated. The renderer uses hardware. Okay, that kind of makes sense. I'd like it to use hardware. That's very nice of it. And then I'm guessing there's something else here as well. Like if I go to G, what if I go like K like that? Oh, perfect. Oh, that's way better than what I was doing before. Okay, so SDL render, aka struct SDL renderer. This takes the SDL window, it takes an index, and then it takes the flags. Okay, create. Oh, this is so perfect. Okay, create a 2D render context for a window. Interesting. So this is where we actually are writing to, I guess. Let's get rid of these things. So this is what we're actually writing to. So if that's null, then yeah. But now we have our sort of quit context, and then we have our SDL event. I'm not entirely sure what this does, so we'll figure that out. Now we have our while not quit. So assumedly we'll, keep moving on until we have quit, which will eventually happen. If I run this, eventually there will come a time when I do have to close my game, which will be very unfortunate. But we have that sort of e.type. This is interesting. Okay, so we have this while. We have this nested while loop, which seems like an interesting way of doing it. I'm not entirely sure. Okay, so let's see. It's going to tell me about each little part of this. Okay, event handling. The program enters the main event loop, polling for SDL events using SDL poll event. If an SDL quit event is received when the user closes the window, the quit variable is set to 1, which will break out of the main loop. Okay, so that makes sense, but I'm still kind of confused as to how exactly this works. So what is sort of like the frame rate, I guess, is one thing that I'm kind of wondering about. I mean, assumedly, like, since this is all like procedural, this is all happening sort of at the same, I don't know, this is all like sort of delaying. It's happening as fast as it can. Okay, render present renderer. Okay, so that's why we need the pointer to this, because yeah, okay, that kind of makes sense. Sorry, I'm rambling a little bit. So we take this, and then it'll update the screen with any rendering performed since the last call. SDL's rendering functions operate on a back buffer. That is, calling a rendering function such as SDL render draw line does not directly put a line on the screen, but rather updates the back buffer. As such, you compose your entire scene and present the composed back buffer to the screen as a complete picture. Interesting. So that's what the render present actually does. So basically we're making all of these different changes. We're setting the render draw color to this. That's interesting. I think that's how we're setting it to white. Yeah, we have RGB. That's what it is. Okay, so we have FF. Interesting. I don't know how to describe. Can you tell me more about the colors? X or 0x FF. I know that that's code or hexadecimal notation, but I don't remember exactly how that works. Okay, hexadecimal representation of the number 255. In computer graphics, the color values are often represented using 8 bits, which can have values ranging from 0 to 255 in decimal, or 0 to FF in hexadecimal. Okay, in SDL2, colors are typically represented using a structure of 4 separate 8-bit values. Okay, so this is an 8-bit value because we're using hexadecimal, which is, I don't know, what does that work again? Hexadecimal is 16 symbols, right? So 0x means use hexadecimal. Then we have 2 Fs, which are, letters of the alphabet that mean some sort of number. I think F means 16, so we have 16 and 16. And that's sort of our, I think so. That's a combination. 0xF or 255 in decimal. Interesting. So I've never really, I've always used hexadecimal, but I've never really had to, learn it. And I know I probably don't have to here, but I'm kind of interested in sort of getting my brain to understand it a little bit better. Okay, so what's 254 in hexadecimal? I'm sure it's going to lie to me, but hallucinate or something. Presented as 0xFE. In hexadecimal, notation, the digits range from 0 to 9 and then continue with A for 10, B for 11, up to F for 15. So in the hexadecimal system, okay, that makes sense. So F isn't 16 because there's a 0 that I forgot about. So F is 15. Okay, the F digit represents 15 in the decimal, and since it's in the 16th place, it contributes, okay, 15 times 16. Since it's in the 16th place, equals 240 to the total value. Wait, what? Okay, now I'm confused again. Since it's in the 16th place, can you count up to like 32 using hexadecimal? I'm not super getting it. Absolutely, I can help you with that. How nice of it. Okay, it's going to draw me a nice little chart here. In hexadecimal, each position from the right represents increasing powers of 16. Oh yeah, that totally makes sense. Okay, that makes a lot more sense because, okay, so F is in the 16th place right here. Okay, so this means 15, and this means 16 times 15. So 16 times 15 plus 15. That makes sense. Okay, so that's why that. And then if I change that to like, an E, and then we save that, we recompile everything, and then we run it. Okay, it's a completely different background color, obviously, as you can see, because we changed literally one value in the white space. But okay, so this makes a lot more sense now. So 32 can be represented by the number 20, and if we're just looking at decimal, then that makes some sense. But we're really seeing like a 2 0 here. That's kind of neat. I kind of have to say that I do like that, because it seems like you can do... Okay, hexadecimal's nice. I can get behind hexadecimal. Anyway, so what do I want the background color to be? I want the background color to be black, which means I use 0, 0, assumedly. I think that's fairly simple stuff. Okay, so let's do that. Let's do a little make, and let's compile this. Oh! Because I gotta do it on these other ones too. Probably doing this extremely inefficiently. I haven't gotten good at macros yet. Another thing that I'm learning is Vim itself, as well as NeoVim. So, there's lots of learning going on in my life at the moment. Alright, there we go. We've got a beautiful black background with a beautiful blue square. My gosh. In the middle of it. Well, not in the middle, but you see the point. Okay, cool. So now we've got that going on. Okay, STL set render draw color. We're gonna render clear. Okay, we're gonna clear the screen, and that makes sense. So this all gets stored in a buffer, which means that I'm guessing these changes happen. Let me do that real quick. In the order that we expect them to happen. It's interesting that you have to... I don't know, this whole graphics language has always seemed a little bit weird to me, right? Because we've got set render draw color, then set render clear. Then we have a rectangle. So we have, we have a rectangle within the origin, with the origin at the upper left integer. So then what we do, we take our variable, we give it, wait, how do we actually, it just told me this, but I forgot it already. So this is empty equals intersection rect. Okay, so I'm guessing this is, width and height. Let's test this. We're going to replace this with a 1. So right now this is a... Is this an array? You tell me about this line. what is it doing? And specifically, what I'm wondering is about this literal syntax. I spelled it wrong. Absolutely. This line of code is creating an instance of the SDLREC structure. Oh, so we're talking about a structure here and initializing it with specific values using a brace enclosed initializer list syntax. Okay, so SDL for field rec, that's the structure. Interesting, so it's a structure. And then the equal symbol is assignment. Yeah, the brace is used to enclose a list of initial values for members of the SDLREC structure. Okay, that makes sense. It is going to be x, y, width, and height. Can you tell me about structures? My gosh, are they the same as structs? I don't know if they're the same as struct. Yeah, structure and struct are used interchangeably. Okay. A structure, or struct, is a composite data type that groups variables under a single name. These variables can... Okay, this is cool. So you can define... oh, I didn't know you could do that. That's kind of neat. Okay. You can define, essentially, specific fields. This makes sense. This isn't like every language at this point. I mean, we have sort of classes in object-oriented languages, so it's kind of a little bit different. Okay, so once defined, you can declare instances like this. Interesting. Accessing members. Then why isn't the line struct and then what I pasted? Great question. The line is technically correct in C, but it can be cumbersome to type out the struct keyword. Honestly, that is entirely true. Every time I type out the struct keyword, I feel like I am losing years of my life. To mitigate this, many C libraries use typedef to create a new name for a struct type, allowing you to refer to it with a struct keyword. Interesting. Typedef? With this typedef, SDLREC is now an alias for the anonymous struct type defined above, and you can declare variables of this type using just... Oh, so you can define types. Interesting. So you can define abstract types using typedef. Indeed, typedef is a powerful feature in C. Oh, okay. Unsigned long int ulong. Oh, that makes so much sense. You know, this is probably like not as mind-blowing to everybody else, but it is certainly Okay, hold on. What? How in the world does that work? We've got a float xy. How does float xy work? Now I'm confused again. How would I use this? Like this? Point variable equals, and then what is it, like 1.0 2.3? Exactly. I got it right. Okay, this is a beautiful moment. This is great because I lose years of my life every time I have to type the word struct. I always like trying to play with humor with ChatGPT. I feel like we got to train it a little bit to be a little funnier. Ha ha, I can understand that. The typedef keyword is indeed a lifesaver in such scenarios. Perfect. Alright, so we've got our perfect little rectangle. Now, one thing I want to do is I want to get sort of the center going on. Let's make not an int center equals And then we're going to do, here's another thing I want to do. I want to make these. So these right now, SDL window, type def struct, SDL window, SDL window. Okay, so we have the SDL window still. Where is this? SDL window. Const void pointer to magic. My gosh. Okay. So that answered 0 of my questions. I broke everything, but I'll fix it in just a second. Okay, so I want to see K. Okay, so we need the title, we need the XY, we need the width and height, and then we need the flags. What in the world does this mean? Define this, and then that gives me this SDL window position undefined display, and then that's okay. So this is brief used. Okay, define this. So we must be, yeah, we're in an H file right now, and then SDL window position undefined mask. What in the world does that mean? You know, I don't think that matters as much to understand. But what I do think matters is, oh, it's just a 0. It just means 0. So we just get 0, 0. Can I just do like, can I just do the, like, 0? Is it going to get mad at me if I do that? Or is it like, that's actually a good idea. Thank you for doing that. Okay, and then we just want to do, for goodness sake. Copilot's so annoying. Okay, int height equals 900, and then we want to do int width. Okay, it's nice sometimes as well. Int, oh, not that time. I'm so bad. I'm such a bad typist. Okay. We want to replace that with width, and we want to replace that with height. And then theoretically, we should also, you know, swap these. Now it's all mad at me, but that's okay. So we're going to do in center. Oh, wow, I messed that up real bad. Let's get that. Not what I meant to do. Let's get that there. Let's go center equals width divided by 2. And then I want, you know, int. So that's the X position. And then I want, oh, you know what? Int center Y equals height divided by 2. And then this needs to be center X equals that. And honestly, you know, I probably don't actually need those to be inside of the while loop. But you know what? We'll do that in just a second. So center X, right? And then we need to do center Y. And then we need the formatter to make my code look pretty again. And then let's try that out. We'll see if that does like anything like what I wanted it to. Oh, I love just unnecessarily compiling code. There we go. Beautiful. So it starts in the center. Obviously it draws past that, but with the width, okay, so now we can just do a little bit of, you know what? It is not a big deal to declare these here. Okay, int width equals center X. I feel like I just need to change how I'm actually doing this. I'm just trying to get this to render actually in the center. So what I want to do is I want to center Y and then sort of minus 100, right? And then I want to do the same thing here, minus, my gosh. See, I'm trying to learn how to touch type as well, but I haven't really been practicing like I'm supposed to. I'm trying to learn everything, guys. Game of life. Bam. We have a square that is blue in the center, and I don't want it to be blue, I want it to be white. Now, making the grid is going to be the next hard part, but I don't actually think it should be that terribly bad. And I don't know, I guess I should make a grid. Okay. Okay, fill rect. And then let's do, we just also want these to be, no, we want this to be F, this to be F, and this to be F, and this to be F. Oh. Make, and then we'll run the game of life executable. Beautiful. And then we just need to be smaller, so let's do, how big do we want this to be? How does this even work? How do we, let's start a new conversation. Is there a set, you know what would be cool? I think, like, you can export your data, right? You can export all of your chat data, and I'm sure you can use this to, like, train up a model using, like, some vector DBs and stuff. I wonder if anybody's done that. I mean, obviously there's, like, history or, like, memory GPT, which is kind of cool, but it shouldn't actually be that hard to kind of, like, get this up and running yourself, like using a vector DB in your own chats. Okay, is there a set height and width to a Conway's game of life implementation? The size of a grid implementation can vary. It is not fixed to a particular height and width. In the classic version of the game of life, the universe is theoretically infinite. However, in practical implementations, the size is determined by the limitations of the computing resources and the specific requirements of the implementation. Okay, there are several ways to implement the grid in Conway's game of life. Fixed size grid. I don't want it to spoil this for me because I want to actually figure it out as an exercise, but this is fine so far. Okay, fixed size grid. You can choose a fixed size for the grid based on your requirements or limitations. This is the simplest and most common implementation. For example, a 100 by 100 grid. Okay, it would be cool to do this. I'd like to, obviously we need to make it a sort of division of these numbers. So what I think I might do is actually do a 9 by 8, 8 by 16, or we can do a 9 by 18. No, 16 is better because we already saw how wide that was. What is full screen? Uint, XY width and height. Okay, what are the width and height measured in here? Oh my gosh. Of course, I should have looked. Web apps are so buggy these days. What units are the width and height arguments supposed to represent? Width and height arguments in the STL creator represent the dimensions. Yes, but like in pixels? Interesting. Okay, so if it's in pixels, really? I mean, technically, no, right? That's not possible. It's not possible that my entire screen, like when I run this, it's like, okay, a pixel or picture element is the smallest controllable element of a picture represented on the screen. Okay, so it's probably not a technical, so it's not technically a screen pixel, but more in arbitrary representation. Term pixel in the context of specifying windows typically refers to a screen pixel, which is the smallest controllable element of a pixel. However, the exact mapping between the dimensions, the physical pixels on your screen can be influenced. Well, yeah, that makes sense. And then the pixel density, okay, yeah, high DPI. Retina displays the operating system may use a scaling factor to map logical pixels to physical pictures. Yeah, that's probably what has to be happening, right? Like, when I run this currently, like, this is not 1600 pixels. 1600 pixels is like a tiny amount of the screen. So that totally makes sense, unless I'm completely wrong, which is possible. Okay. That makes sense though. So we have the width and the height. That's just of our actual, like, window, and then we're gonna make the grid spaces. Int grid spaces. Oh, I guess I could. No, I need grid width equals, and we're gonna do the width, and then however much we want every one of the squares to be. So we'll make that 10, just to make this simple. And then we want int grid height, which is also going to be 10. Oh my gosh. I have no idea what it's doing right now. Grid height equals height divided by 10. Yeah, that works. Yeah, so one thing that sucks about NeoBIM is like little things like that, where it's like the IntelliSense comes up and Copilot comes up at the same time. That just does what you expect in VS Code, but it doesn't do that in NeoBIM. So that's kind of the annoying thing. Which, like, yeah, okay. So that's going to be the grid width and height, because this is going to be the size of the pixel, and so then we'll do int space size, which is going to be 10. Oh my gosh. Sorry guys, I don't like typing, so I make myself do it more. By being really bad at it. Okay, space size, there we go. Yeah, I've got fat fingers, we'll say that much. Okay, so we don't actually need this thing, even though I spent all that time doing this. Like, I really don't need that. Use of undeclared identifier, fill rect. Yeah, I don't need that. Set render draw color. Alright, so now let's do should we make this a function, or should I just define just like I mean, I feel like I need to abstract the grid rendering itself to like its own function. So we're gonna do that. We're gonna do func, right? No, it's not func. It's the data type that it represents, which is, how are we gonna return this? Void, right? Okay. How might I implement? No, I don't want to ask it that. Oh, it's already going to do that for me. Of course it is. Okay, so we get the renderer, and then let's just disable Copilot, actually. Just Copilot disable. There we go. But it was right. So I want to, okay, that's nice. That's all that I really wanted. Render grid. I want to say draw grid though, because draw grid is cool. So first we need the SDL renderer. Right, now we need that to be a pointer to a renderer. Right? Is that how these guys do it? Like, this needs a renderer, so is that how? That's not useful. I just need a... Okay, whatever. Need the pointer to a renderer. Grid height. Okay, perfect. And then let's actually draw this. So we take the renderer, and then we need, okay, set, and then maybe we need grid color as well. Set render draw color. So in DrawGrid, we get our renderer. So we need SDL set. Well, we can just copy this up here because we want this to be it essentially. So we can take this and we can set the render draw color to white. Now that being said, we might go with some kind of like gray, color picker, right? If I do a color picker, it's gonna, yeah, perfect. It's exactly what I want. And then it gives me this RGB values, but then it gives me the hex values as well. And that's what I want. So give me like some nice, like space gray, hexcolors.com or color hex, that's what it is. Like space gray. Or give me just the gray. Space. Fine, take me to Adobe Colors. I want like a nice color palette, you know? Like I don't want just like a dumb color palette. So let's do space gray. Bam. Space gray. Let's go with this one. I like that. So that's we can go back here. I know I'm using too much I'm using too much of the mouse over here. Okay, so we've got 40, so 4 0. Oh. And then we've got 3D. So 3 and then RD. And then we've got right. Okay, so this is 3C. Okay, 3 and then RC. And then this is the alpha channel. So this is a different channel. This isn't going to affect our color, although we might play with that for the transparency. Okay, so we set the render color to that, and then what we just want to do is okay, so let's make int one. So we want an array, which is, I think this is how to do this, which is you know, 2-dimensional. Actually, wait, I'm doing that totally wrong. Okay, so we have a 2-dimensional array, and then we have position, or like, you know, current position equals, and then we need to do, shoot, how do I make an array? Manipulate the elements in C. So I need to know how to make an array, and then that's going to represent the X and the Y, and then we're just going to, okay, so int array, oh, of course, so int is the data type itself. Interesting. You can initialize the array at the time of declaration, or you can assign values to individual elements later. Beautiful. So we'll initialize that. Okay, so I'm doing this completely wrong. Okay, current position, and then that's going to have a width of 2, and then there we can do a 1, and then a 1, and then that will be the multiplier that we use. So we multiply that by the grid width. That's not what we want. Hold on. Oh, wait. We do want those things. So, okay, perfect. Now, for goodness sake. Perfect. So we have the space size up here. Okay, cool. So now we're going to go down to, I'm going to go back down here. We're going to want the space size as well. So let's do int space size. And then we're going to do for let I equal 0 as long as I is less than. Do we want to do a for loop? Is this the right way to do this? I mean, I guess it is, isn't it? So we'll just do as long as I is less than the grid height. We can do this in either columns or grids, right? Or rows. And so what I think I'm going to do is by rows, basically going to do this row, then we move down to the next row, you know, something like that. So the current position is going to start at 1 by 1, and then we're just going to go through sort of each individual thing, and we're going to multiply it. You'll see. I'm going to have to play with this because I'm not super good at math. So I'm like trying to work this out in my head, how it'll work. Okay, undeclared identifier. Oh, because I did freaking let. Oh my gosh. Sorry, my freaking JavaScript brain is coming in here. Int. There we go. Okay, so int I is going to represent, and I should probably just actually name this. We're going to call this R. Oh my gosh. Row. Row is 0. And as long as row is less than grid height, we're going to increment row. So this is row. Now we need to do for int call equals 0 as long as call is less than grid width. Then we're going to do row our call plus. Okay, so we have a nested for loop here, but that's fine. C's fast, right? And then we're gonna do. How are we gonna do this? So we need the starting position. Start. We need the x. Int x equals. I guess we can just use this, right? Do we want to? I don't think we need to. I think I'm just doing this wrong. I'm just making this more hard for myself. Okay, so we're going to do int x. And int x is going to equal the current column times the space size, right? So that's basically going to be like whatever column we're on. If we're on column 13, then x needs to start at 130. And then we're going to do a y, int y, that's x, equals row also times the space size. So theoretically then, we can do SDL, and then we can do render square rectangle. I messed this up because I didn't save a reference earlier to what the rectangle looked like. Create window, create renderer, dollar color, fill rect. That's what it is. Render fill rect. Render fill SDL. Render fill. What? Yeah, it's SDL render fill rect, isn't it? I sent something in here as well. Yeah, it's render fill rect. Oh my gosh. Oh, because I need to actually define the rect first. Okay, that makes sense. SDL rect. I'm so freaking brain dead at the moment. How do I set it? It's like that. SDL rect. Okay, so it is lowercase rect, and then we need to do square grid, we're just going to call it square. And then square is we're going to give it the old x, y, and then grid space size, and then space size. So this is so that this is all like modular, and then we need to do the render fill rect. But we don't want it to be filled. how can I render a rectangle with just a border instead of filling it? Because, like, what I'm thinking is we could make them transparent and have them slightly overlap, but that's not really what we want to do. Render with just a border. Instead of filling it, you would use the STL render draw rect function, unless, oh, we do draw rect. Of course. Okay, hold on. Yeah. You don't have to show me the entire file, by the way, just the part that I need to know. I try not to be like snarky or anything. Got it. Here's the specific change you need to make. Okay, perfect. Yeah, so that's nice. It set the render draw color, perfect. Outline rect, the square, and then we give it the renderer and then a reference to the outline rect. Okay, no. I do actually want to see this because I want to know. So the renderer is, yeah, okay, so I did this right. We needed a pointer variable. What is a pointer variable? Before it says it, I think it is a variable that points to a memory address. Yes, perfect, freaking yes, okay. Sorry, I'm getting a little too excited here. Okay, SDL draw rect, render draw rect. Yeah, I can use that. Render draw rect. Okay, then we give it the renderer, so that's the renderer, and then we give it, how do constants work in C? I know, like, this isn't a big deal, but I need to figure, I just want to know, like, kind of how this works. Constants in C are values that cannot be altered after they are defined during compilation. They are crucial for making code more readable and maintainable by providing meaningful names for values. Okay, literal constants. Literal constants are values inserted directly into the code. Okay. Define preprocessor directive. Is that like what a macro is? Preprocessor directive? I feel like it's not, but like kinda. Const keyword. The const keyword allows you to declare variables whose value should not be able to change. Constant. Oh, okay. You know what? So let's go up here and let's make these all constants because I think that that's a good use case for them. I'm not entirely dumb. I know things should be constant. I just don't know how to do it fast. Okay, look. My formatter will do the heavy lifting for me, so I don't need to make it pretty. Can you imagine not having a formatter? Can you imagine being like Ken Thompson and was it Dennis Ritchie and just like writing C in the first place and not having a formatter? You got to do that all yourself, and you're using like a line-based editor in Unix. Like, my gosh. Okay, so let's go down a little bit. I forgot how to go down. Oh, I'm brain dead. That's not how. What in the world? Constant. Okay, yeah, that's what I want to do. There we go. Okay, yeah, sorry guys. I am tired. I will admit that freely. Okay, so we have int x and int y, and then we're going to come over here, we're going to go to render, and then what we need inside of here is a pointer to the rectangle that we just made, not to delete it, although some might say, oh my gosh, renderer, and then inside of here we need the reference to the square, and then there we go. We have a beautiful. Now, who wants to bet me $5 that this will crash my program? Let's see if we can use it. So, draw grid. Expected. Oh, you know what? Call to undeclared function. ICO C19 and later do not, or ISO. Okay, so that standard doesn't support implicit function declarations, and then conflicting types for draw grid. Oh yeah, okay, so there's no implicit function declaration, so I bet I have to come up here, right, and say like void draw grid, and actually just like copy that same freaking declaration from like right here, like that, and then we'll just do a yank and then come back up here and then put that, and then bam. What, is everybody happy now? Oh, frick. No, not everybody's happy. In fact, everybody's really mad. Wait, I want that. Okay, now let's go over here. Let's X that out. And then, yeah, like that. Okay, now what is mad about? Too few arguments to function call. Expected for, have 0. That is too few arguments, I will admit. It was a little bit rude not to give it more. So we need to give it a, what, reference to the renderer? Renderer, okay. And then we need to give it the grid width. We need to give it the grid height. And then we need to give it the space size, right? Does that seem right? Incompatible pointer types, passing. Oh yeah, we don't need to do that because this is already a pointer variable, isn't it? Alright, so I can just give it renderer. Oh, why are these even open? Okay, so perfect. So now we'll come over here and do the make and game of life thing, and then no freaking way. I'm gonna be honest with you guys. I was about 400% sure that would not work first try. But here we are, we have a grid, and I feel like a genius. Now, we haven't gotten to the part where I feel dumb because it stops working, but that's okay. We're at the nice part of writing a program. So, let's see, we've got constant width, we've got constant height, we've got the space size. Okay, cool. I didn't like how small those things were, so I'm going to make these a little bit bigger. And because I made this all modular, yes, I made it modular, and I feel very happy with myself for doing that, because now I can do 20 instead. I can make those bad boys twice as big, and theoretically, they should still work, although it may not. Okay, yeah, see, that looks like way better in my opinion. And it even lines up right at the end. Oh man, that is just so nice. Okay. Should I make this? Okay, I feel like one thing that I do need to do though is instead of making it like, 16 by 800, I feel like I should just make it like 1,000 by 1,000. I feel like it should just be square. I feel like that'll make my life a lot easier. So let's do that. We like that. Oh, it's a little annoying that it doesn't show up like entirely. So I'm going to make it 800 by 800, and that should do it though. So yeah, I guess we can do 900. 100. Keep in mind, I'm not very good at typing. Perfect. That's amazing. I'm really happy with that. So I have a grid going on. I don't want to do any premature optimization, but I do want to make sure I'm not doing anything stupid for now. Am I doing any memory leaks? How do you even identify a memory leak? What does a memory leak look like in C? Memory leak occurs in a C program when dynamically allocated memory is not freed. Okay, so when pointers to allocated memory go out of scope or are reassigned without freeing the original memory. Here's an example to illustrate a memory leak. Okay, so we have to use malloc in order to do that. So we're going to allocate memory. Interesting. So allocates 100 bytes of memory, and then we change the pointer to null, and then we just don't do anything. And so there's just memory that's being stolen. Okay, cool. So why might I use malloc and free in a typical program. That's what I'm wondering. Free allocation is crucial for dynamic memory management, which allows you to allocate. Okay, so I've never done any dynamic memory management. I will be honest about that. Although, obviously, it's useful. So, which allows you to allocate memory space for your variables at runtime, along with the ability to acquire more space. Okay, so type def. We're going to give ourselves a node. We're going to say node new node. Okay, we're going to say a pointer to a node pointer. You have data structures that grow or shrink at runtime, like linked lists, trees, graphs, or hash tables. Dynamic memory allocation is essential. Oh, so we have a node here, and then we need to be able to allocate the size of the node. You know what? I'm going to not worry too much about this right now. It kind of makes sense, not that much though. Although I am wondering, why is the star on the type and not the variable here? So we can create a buffer. That kind of makes sense, right? Like you got to use that at some. Okay, in the line char star buffer equals char star buffer, or the asterisk can be placed either next to the type or next to the variable. Both of these declarations are equivalent in C, and the choice between the matter is coding style. So you could also write the line as, oh, style emphasizes the type of the variable, which is the pointer to a char. Some programmers prefer this style because it clearly indicates that buffers is a, oh, that kind of makes sense. Okay, the style emphasizes the variable itself and is a visual reminder that the variable buffer is a pointer. Frick, both of those are really good reasons. Okay, but let's be real. Just because you declare it like that, you're not going to look at it until you... Oh, man, I don't know. I think I'm leaning towards the first option. I'm going to have to do some redoing here. So, you know what? I'm leaning towards the first option, but frankly, I don't really want to redo these right now. Oh my gosh. Okay, so let's do that, and then let's add the little star there. Bam. And then let's add the little star here as well, and we'll get rid of this. And then let's just see star dot. So, okay, so draw grid, and here we, oh my gosh, why did I make this so complicated for myself? You know what? We're not dealing with that right now. That's literally semantics and syntax. Like, we really don't need to be worrying about that at the moment. We need to be worrying about drawing little squares. So what we need is in sort of like an initial grid function. So let's go up here and let's do void draw, or let's do update I want to kind of take a little bit more of a functional approach, so we're going to pass a game state object. So what I'm thinking, first of all, is that we need a game state struct. So we'll do struct game, we'll do type def struct, right? And then we'll do that, and then we'll say this is game state, and then like that. Okay, perfect. Now in type def struct, we're going to first give this the frame, which is an int frame, right? Let me tell me how to use structs again, please. And then how in the world int and elaborate on this one, because it looks like there's actually like function logic doing. Oh wait, you know what? this returns a pointer to an, oh my gosh. Okay, I was so confused by this because I thought that this was like a declaration, but it isn't. Okay, so type def, okay, so we have int data, and then we have struct, which is going to be a pointer to a node, and then we're going to call it, okay, no, I'm still a little confused, actually. Okay, certainly, working with the code snippet you provided, blah, 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 short declaration with type def, so we're going to give this type def struct node, and then that's going to basically be in data struct. Okay, new struct name node. It's being defined with type def. This struct has two members, data, which is an integer value, and then next, which is a pointer to another node, struct. Oh, so this is the type. Okay, so theoretically you could rewrite this though, but that makes sense. Okay, node. That's the name of the type definition. Then we have the typedef keyword is used to create an alias for struct node, so that you can simply use node instead of struct node. Yeah, that makes sense. So then we have the new node, which returns the pointer to a node, and then it takes an int of data. So then we have a node, which is a node allocated to the size of the node. How in the world does that work? Okay, hold on. In this function, a new node is dynamically allocated using malloc. The data member of the new node is set to the data parameter passed to the function. The next member of the new node is initialized to null, indicating that this node does not yet point to another node. The function returns a pointer to the newly created node. This new node function is a common way to encapsulate the creation of new nodes in a linked list. It abstracts away the memory allocation and initialization details, making it easier to create new nodes. Okay, very interesting. I'm going to have to learn more about that in this data structures in C++ course that I'm trying to look through, but for now, all we need to know is that we can have the int frame, and then, okay, so this is the difficult part, right? So how in the world, okay, wonder if there's a way to describe this game state. So the issue is, like, I need to be able to describe a grid. Is there a way to do, so say I want to have a struct like this, struct game state, and then game state has, you know, frame, which is an integer, and then game state also has, I need to track a grid and which spaces are currently filled versus not filled. In order to track a grid with information about which spaces are filled and not filled, you could use a two-dimensional array. Yeah, I mean, that's what I'm thinking, but, like, the only issue is I don't know how to. Yeah, grid rows. Yeah, okay. So I could define those as a preprocessor. What is that? Preprocessor something? Okay, hold on. Grid space is a struct. Game state, yeah, I can initialize. Yep, grid space. I'm using an enum instead of a simple int for the filled member of grid space. That makes sense. I could definitely use that. It allows you to easily check and update whether a space is filled for better readability and a more complex state tracking. Okay, tell me about enums, but also about these preprocessor directives. I want to know about these preprocessor directives, because it looks like I can just use this define, you know, that to something. The thing is, what I wonder though, like, does it dynamically decide what that is? How in the world does it know? Okay, enumerations. Enum day can be one of all of these choices. Enum, by default, Sunday will have a value of 0. Oh, okay, interesting. So this is actually something, there's a similar phenomenon to this, I think, in Golang, which is interesting to see sort of this play into both C and Golang. But yeah, so enum day equals 1. Yeah, you can offset that if you want to, and then day to day equals Monday. So it can only be one of those ones. Preprocessor directives are instructions to the C processor, which is part of the compiler that processes the code. Define. This directive allows you to define a macro. Oh, so it is a macro. A macro is just a preprocessor directive. I'm guessing that those are a similar thing. Basically means like before the code runs, like everything gets. This is just a way to tell the processor to, like the compiler to do something. Instructions to the C preprocessor, which is a part of the compiler that processes your code before compilation. Include. This directive is used to include the contents of a file in your program. Oh, so this itself means that it's a preprocessor directive. Okay, so then if def, if ndef, if else, and elif and endif, these directives allow for conditional compilation, which can be used to include or exclude parts of code based on certain conditions. That is so interesting. Debug mode active. That's actually so cool. Okay, undef pi. Undefine a macro. Then pragma. This directive is used to provide additional information to the compiler, such as to suppress warnings or okay. In this line, though, like, so in this define directive, how does it know the type of these variables? That's a great question. I thought it would say that, but it didn't. Okay, the define directive in C doesn't have type information. It's a textual substitution mechanism performed by the preprocessor before the actual compilation begins. Yeah, it's a textual substitution, but if I'm going to put it in something that's typed, how in the world does it work? Placed by a 3.1, okay, wherever it's used in the code, the type is inferred from the context in which it's used. Oh, because I guess, oh, I'm so dumb. I don't know why I didn't realize this. So grid space is an int, which is either filled or not filled. And then, okay, so this is an integer filled, and then grid space. Okay, so because this is an integer, that defines that. Okay, you know what? Whatever. That totally makes sense. So filled and okay, so that's what we're gonna do. So int, let's do type def grid space. Oh wait, no, we don't need grid space there. We want type def struct, and then we're gonna give this a grid space. That's going to be its name, but inside of here we're going to say filled, and that's going to be a property of it, which is going to be an integer. And then over here we just got to put if I just put a semicolon there, it'll fix it. Okay, perfect. And then we need we need grid space board, which is going to be, let's give some preprocessor directives in here. Define width. Let's just define all of these things. Width is going to be 800. We're going to do define height, which is also going to be 800. We're going to define the, oh, so since it's a preprocessor, it just replaces the text. Of course. Okay, define height, define, and then we need to do, space size, which is going to be that, and then we're going to define, and then we're going to define grid width, which is going to be equal to width divided by space size, and then we need to define grid height, which is going to be equal to height divided by space size, right? Now, okay, cool. ISO requires white space after the macro name. Oh, I didn't give this an actual, like, okay, I need to give that 20. Perfect. Now, down here, what I can do, instead of having to replace all those variable names, I think I can just do width and then down here I can do height. This is absolutely fascinating. I don't care what anybody says. This is so cool. Space size. I bet there's like people who say that you shouldn't use these, and I'm sure that there's a perfectly good reason for that. Okay, grid width, but I don't care. I'm gonna use them anyway. Let's do that. Let's do, grid height. Bam. Okay. Expected expression. Oh, come on. That's kind of an expression. What does that mean? Why is this expected expression? You know. Oh, that's not what I meant to do. Let's go up here, because that should be width. Whoa. Whoa. Width. What in the world? Why is it doing that? YG. I don't need wide. I need that to, like, what is that, line 38? Is the point of this error. I don't know what the heck that means. Why is it mad about? Because you incorrect use of define directive. What? You have an equal sign, which is not needed and indeed incorrect. Oh, I have an equal sign? Oh. Okay, yeah, I do maybe perhaps have an equal sign there. How was I supposed to know I wasn't supposed to have one? Okay, that wasn't the only thing. And then I need to surround it all by, okay, of course I also need to surround it. Oh my gosh. Oh my gosh. Okay, I don't know what the heck, where are my fingers right now? Okay, let's do, I want visual mode. How am I bound at V? What that, okay, this makes no sense. I'm sorry, I'm so bad with Vim. I want to get better. I really do. And I'm really working on it, but you have to bear with me here because I'm actually really slow. Okay, there we go. Expected at the end of declaration list, fix available. That's probably what it means, right? And then inside of here, okay, finally. So now I can have the actual grid width. Okay, wait. We're doing, to draw the grid, we're doing rows first, which is the height. So I should do that here as well, even if I don't want to. Grid height, and then grid width. I think that makes the most sense anyway. Type name requires a specifier or qualifier. Okay, what? I feel like I'm still doing this wrong. Constant. Now, when you use in your code, they should work as expected. Grid width equals grid width. Also, in your game state strict declaration. Okay, so it's still mad at me, though. That's the thing. The board member is declared as an array, but without a size or pointer type. Yeah, I know. I know. I get that. You need to specify. Yeah, I know what I need to do. But why is it getting mad at me now? Come on. Read it again. Are you sure? Okay. I'm gonna complain to ChatGPT more. I'm still getting expected expression. I'm also getting... The other annoying thing is, like, there's no way I can copy this because it's not in its own little buffer. There's probably a way I can copy it. Type name requires a specifier or qualifier. A specifier... You guys probably don't want to watch me debug this whole time, but I'll probably end it here soon. Or qualifier on the board member line. Bam. Now it's going to be like, here's the solution to all your problems. Issues you're encountering are due to some syntax mistakes. Of course they are. Expected expression error. The defined directives should not have semicolons at the end. Oh, of course I also put semicolons. Oh man, you can't have semicolons either. Come on, fix everything, please. Okay, so they can't have semicolons. Now they're supposedly right, but they're still mad. It's probably something super obvious. Type name requires a specifier or qualifier. Okay. This error occurs because the grid space type is not known at the time the compiler is trying to process the game state struct. Ensure that the grid space is defined before game space or game state if they are in separate files. Yeah, but they're right next to each other. You can see where they're defined. I'm defining it there. Now your code should compile without the expected expression. Yeah, but it's not gonna, because it still doesn't work. Okay, let's get all those up and running there. Okay. Type def struct. This is literally what it looks like, and it didn't have me change anything. Right? Am I dumb? Let me get this. And let's just paste it in there. And I'm sure it'll work now because... Okay, you know what I'm going to do? I'm going to do a WQA, and I'm just going to re-enter lvim. That literally didn't fix it. Apologies for the oversight. Upon reviewing your code again, it seems like the define corrective should be placed before the type def declarations. They are. And at the end of define directions should be removed as previously mentioned. Yeah, but like that's what I was doing. I didn't do it in reverse order. These are all defined before these that are. Type name requires a specifier or identifier. Okay, you know what? Game of life rules. That's what I need to know. Give me the game of life rules for Conway. And then, okay, Conway's game of life. If the cell is alive, then it stays alive. Okay. And we also need to, instead of calling this frame, we need to call this generation, because that sounds way more scientific. If the cell is alive, then it stays alive. Okay, hold on. Of life. Initial pattern is the first generation. Okay, and instead of filled, we're going to call this alive, and we're going to call this cell. Cell. And then, instead of board, we're going to call this, world. And then, instead of grid space, wait. No, that's... Still doesn't make any sense. Cell. So the cell can either be alive or it can be, and then we have preprocessor macros here, which like the fact that they're not working is really annoying to me, because type name requires a specific okay. It didn't. Here's what I currently have. We're gonna do that, and then we're gonna do like that, and we're gonna Y that. See the issue now. The semicolons at the end of your define directives should be removed. I don't have semicolons. There are no semicolons at the end of my define directives. Oh, frick. Of course. Oh my gosh. I'm so dumb. I'm so unbelievably annoyed at myself. Okay. My gosh. That whole time they were already there. Okay. Whatever. So, cell int alive. Now, grid height, I still don't know how that's inferred. I guess probably because world is an array and there's no other thing that can be the type of that. So that, I guess, makes actually a lot more sense, and I've just been running a fool's errand this entire time trying to figure out how that works. So type def struct, type def int. So we basically have a world. A world is full of cells. Each cell can be alive. And then the actual game state is going to hold the generations. Okay, cool. So now what I want to do is I want to define sort of in initial const int initial world. And then this is going to be 0. Actually, hold on. Yeah, I do want that. Initial cells. And then each cell, okay. So each cell is just going to exist at a given position, but so there are a couple of ways to do this, right? Each individual cell can be defined, and then if that cell will hold information about its current position, and then like essentially like this, right? Like the cell can hold like int x and then int y. Now that's all fun and games, except then when we want to make the checks, unless I'm completely wrong about this, and I actually could probably do both at once, then if you want to make the checks, then you have to basically do an O of n check through each position. That being said, I probably don't necessarily have to do that, and this could... Okay, yeah, I'm going to do a combination of both, actually. That's way smarter. So basically I can define a list of these initial cells, which is going to be const blah, blah, blah. No, I don't want to do that. I do want to come back over here. I want to get rid of that. I want to make that cell. I want to come back over here. I want to get rid of that. I want to make that initial cell in this literal syntax. Okay. In C, to initialize an array of structs, you would typically define each struct individually within curly braces and separate, okay, first cell alive at position 0. Oh, interesting. So this is how structs work. So, oh, I'm very, very intrigued. That is not how I thought that this worked at all. Okay, you know what? That's fine. Here's what we're going to do. We're going to go, bam. Wait. There are other syntax methods. For example, instead of positionally defining members, defining by name. Because what it's trying to get me to do here is some sort of like dot syntax, which I want to kind of see. Interesting. Yes, indeed. You can use designated initializers to specify the values of specific members of a struct by name rather than position. This feature is especially useful for clarity and for initializing structs with many members where only a few need specific values. Oh, that's so useful. Okay. I mean, I don't really care, but for like readability though, like think about it. Alive is going to be 0. Actually, alive is going to be 1. Because those are the initial cells. These are the initial, like, alives. That's going to be y. And then that's just going to be, like... Okay. Designator and initializer for scalar type int. I'm getting... Tell me about the error. Tell me what the fix is, ChatGPT, please. Error in... Oh, wait, hold on. Designator in initializer for scalar. Oh my gosh, that's like 3 words I don't know. Type int. The code snippet you've shown is attempting to initialize a single cell struct, but it's using an extra set of curly braces as if it were initializing an array of cell structs. This is why you're getting the error. It's trying to initialize that. Oh, because I don't... Oh my gosh. Okay, hold on. Because I need that, right? Okay, that made it better. It's happy about that. It's like, you know what? I can get behind this. So, we're just going to do this for each generation. And then I want to come up here, and I want to define the FPS, because I want 60 FPS. And, okay, let's do this. Instead of 60 FPS, I just want like 1 to start out. 1 frame per second. Now, okay, how do I handle delays in C? I hope there's like some intuitive just delay function. Sleep function. POSIX compliance systems. Oh, so this might not work on Microsoft. USleep, also provided by POSIX, pauses the program execution for a specific number of microseconds. NanoSleep function provides high-resolution sleeping for a specified amount of time in seconds. Include SDL delay. That's what I want. SDL delay. Okay, let's go into the while loop and let's put our SDL delay. And I want that at the beginning. Do I? Yeah, I do. SDL delay. I might not. About SDL delay. That's what I want to know more about. I'm gonna need to go to bed here in a minute. Okay. SDL delay function. Okay. Yeah, that makes sense. I just want to know, like, okay, so that's milliseconds. Oh, which is why we're dividing it. Okay, that makes sense. SDL delay. Delay for 3 seconds. So we're doing 1,000. Okay, yeah. I miss FPS. That makes total sense. Let's do that. Let's do that. Okay, so we have that going on. I just want to draw this, basically. So we're going to do void draw. Well, you know what? I need to come back up here. I need to get this up and running here first. Okay, so void draw board. And what this is going to take is it is going to take a game state. Get out of here, Copilot. Trying to do this all for me. Okay, declared game state, which is going to just be an actual it's actually going to be a pointer to the game state because we need to be able to modify it inside of that. And then we're going to do the int. What do I need? I think I need to call this update board instead because I think that's more semantically correct. Update board. And then down here, I need to do a little bit of a steel render draw color, render clear renderer, set render draw color, render clear, and then we need a draw grid, and then we need an update board, and then game state. We're gonna give this the game state, and then we're gonna give this. We need an initial game state, don't we? Let's do that. Yeah, const initial game state. And then that's the game. Yeah, I'm losing my marbles here. Okay, let's do end. And then, oh my gosh. Yeah, that was so annoying. Okay. What in the world, man? What are we doing here? Equals. And then let's use this literal syntax again. And then we'll do dot generation, which is going to be type the right character challenge. Generation 0. We'll call it generation 1. We can use a 1 index. There's no 0th then generation. There has to be a first one. You know, it makes more sense in this particular context. And then the world itself is going to be the initial cells. Bam. Expected. Wait. Is that wrong? Expected 0. Oh, yeah. I do need that. Compatible pointer to integer conversion, initializing int with expression of type const cell 1. What? Oh, because this is, okay, hold on. Initial world. Oh wait, yeah, no, this is just initial cells. The initial world is different. Okay, so these are just the initial cells, and then the world I need to actually build. Okay, const initial world it can't be a const. It needs to be a cell initial world equals cell initial world, and then we need to go for int I equals 0 as long as 0 is less than, wait, as long as I is less than, how do I get the size of an array? I'm guessing it's just like size. So it'd be a bit tricky as arrays do not store their size. The size of operator, get the size of the array in bytes, and then divide that by the size of one element to get size of, what? Fascinating. Okay, so it's not straightforward to get the size of an array. Code snippet. We define when working in arrays and common practice pass the size of the array as a separate parameter. Of course. Of course that's the common practice. So it can't just make it simple. It can just do everything for me. What the heck, man? Okay, we're gonna do num cells, and we're going to do const num cells, which is going to equal, oh wait, int num cells, which is going to equal 1. Length array folded to constant array as an extension. I don't know what that means. I do not want to know what that means right now. And it's just a warning, so I'm just going to ignore it for now. That's going to be really important later. I know it is. Okay. Num cells. Did it go away? No, it's still there. And then we're going to do I++. So we're basically just going to go through each of the cells. We're going to go through... Oh, wait. No. What am I doing? What am I doing? We don't even need that. Oh my gosh, I'm so dumb. I'm so unbelievably dumb. We're just gonna have that figured out. Okay, expected expression. Now, inside of here, for I inside of, okay, so actually, you know what? Instead of doing that, we're actually gonna come up here. Oh man, I need to go to bed soon. Okay, hold on. Void. And we're actually not going to get void. We're going to do get, we're going to do cell array initial. How do I express that a function returns its an array of a given type. And C, functions cannot return arrays directly. What? They can return pointers to arrays? That kind of makes sense. Okay, well that's fine. I'll just return a pointer to an array then. We'll do cell like that, right? Okay. Initial, we'll do get initial world, and then this will be a pointer to an array, and so the actual thing that we need to begin with is initial cells, which is going to be a cell pointer, right? I define an array should be passed to an array as a parameter. I'm gonna have to put this away here in a minute, like soon, couple like 3 minutes or so, but okay, yeah, I know I need, okay. So the array, we just have to figure that out, I guess. So cell initial state, okay, yeah. So that's the definition. And then we can go Control D, like so, declared identifier game state, yeah, update board, use of undeclared identifier game state. Oh, you know what? Get initial world, no, we're gonna do get initial game state, and that's what it's gonna be, cell, and then we're gonna call this first generation, and then that's going to be an int first generation. Okay, so now there's an undeclared game state, so that's the constant initial game state, and then that instead is actually going to be hold on, let's use some visual mode, get rid of that, and then come over here, equals, and then, okay, get initial game state, first generation, which is just going to be 1. And then cell is going to be, yeah, I know that's what it needs to be. Okay, so cell, then we're going to do a reference to initial cells, right? Initializing const game state with an expression of incompatible type cell pointer. Yeah, I guess that's fair, because that isn't going to return that anymore. That's going to return the whole game state. So it's going to return a pointer to the game state object. Can I get rid of that? Interesting. So I can return a struct, but not in array. Or can I only return primitives? Yes, that's correct. And see, you can return a struct from a function, but you cannot return an array. Okay, cool. So I'm just going to return a copy of that because I'm not going to need to update it. And I'm pretty sure that's the main way that you... Okay, game state, update board. So I'm just going to call this game state instead. Get initial game state. Passing const game state to parameter of incompatible type game state. Well, I mean, that just means I need to give it a reference, right? Passing const game state discards qualifiers. It discards qualifiers. Oh, you know what? We'll make this a pointer variable, and then we'll get rid of... We'll just get rid of that, right? Would that work? Initializing const game state with an expression of incompatible type game state. What? Tell me about this. You know what? I'll return a freaking... That makes sense, actually. I know why I did that. Okay, hold on. Let's go back up here. Let's go over here. Let's do that. I'll return a freaking pointer. Compatible type. Yeah. Okay, we'll do that. Initializing const game state with an expression of incompatible type game state. Dereference with star. Oh, I have to dereference it. Of course. So, now, we'll do that. Oh my gosh, I'm so freaking annoyed right now. Why in the world? What's wrong with this? Okay, this is what people get annoyed about with pointers, I'm guessing. Is just like, they're a little bit annoying to wrap your head around. And I'm at that point where I just want to do, like, type a bunch of stuff. Okay. Okay, fair enough. You know what? That shouldn't be like that. Initializing const game state. Incompatible pointer types. Passing const cell to parameter of type cell. And then pass const game state to parameter of incompatible type. So game state as it stands, this needs to be a pointer. I need that to be a pointer. I need that type of that to be a pointer, and that's the interesting thing. So I need this to actually return a pointer to game state, and then I'm going to come back down here, and then it's telling me incompatible pointer types passing. Okay, what if I get rid of that? Passing const cell 1 to parameter of types discards qualifiers. Okay, so what if I go over here? Const cell, just going to actually do that. Designator of initializer for scalar type const cell. Oh my gosh. I don't know what that means. Designator in initializer for scalar type. Okay, I think I found the really annoying part of C, guys. Tell you what. I'm going to end it here. I'm going to try to fix these bugs, and then when I come back, I will try to figure out how to actually, you know, do kind of the rest of this whole spiel. Right now, it's just like, it's a little too late for me. I'm not going to figure much out right now. So, thank you guys for watching, if you're still here for some reason. And, yeah, it was nice kind of hanging out with all you guys. Goodbye.